What's up, friends? It's another day of school, so of course, yeah, I'm not here. Charlie, my little one, he might have been exposed to COVID, so we're hanging out and might be on quarantine for a bit. I'll let you guys know more information when I've got more info because right now it's about 11 o'clock on Sunday night. So, yeah, so I thought I'd do this lesson for you to help you through Monday. And yeah, that's it. I'm going to just get going and not waste so much time. All right, sounds good. Now we're going to talk about equalities and inequalities and equations. Inequalities and equations are basically the same thing. It's just that equations have two sides that are equal and inequalities have two sides that are not equal. So an equation will have this symbol somewhere and inequalities will have those symbols somewhere. Pretty simple, right? Right. So let's carry on. So take a look. We have our friend Serena. She gets 2 bags of apples and 1 bag of 8 oranges. Each bag has the same number of apples. Are there more oranges or apples? Huh. Interesting. So you can use algebraic expressions with these inequalities and equations. Boom, 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 boom. Are there more oranges or apples? I wonder what they want us to do here. I wonder if we're missing something. Let's see. So let each bag contain x apples. So x plus x is 2x. So there are 2x apples. To compare 2x and 8, you would need to know the value of x. If x equals 3, 2x equals 2 times 3 equals 6. So 6 would be less than 8, and then 2x would be less than 8. If there's 3 apples in a bag, then there are more oranges than apples. Okay. If x equals 4, so if there's 4 apples in a bag, okay, this is starting to make sense to me. Okay. If 2x is blank compared to 8. Okay. If x equals 3, 2 times 3 is 6, then it's less than 8. If x equals 4, then 2x equals 8. And say if x equals 5, then 2x is greater than 8. I think this is what they're getting at here. Let's go back to that first page and take a look. But I think that's all they're trying to tell us. Yeah. All right. So the bottom line they're trying to get to is if you have it written as 2x equals 8, that's an equation because it's representing two things that are equal. If you have 2x is less than 8 or 2x is greater than 8, then those are inequalities. All right, that's a lot of words to basically say things are either equal or they're not. Okay. Let's see. Complete each of these with greater than, less than, or equal to, and notice for each one it gives you a value to input for y. Pause me, and then I'm going to start ripping through them in about 5 seconds. Okay, I'll see you in a couple seconds. Work. Okay, when y equals 6, 3y is equal to. 3 times 6 is 18, that's equal. When y is 10, 3 times 10 is 30, that's greater than 18. When y is 5, 3 times y is 15, which is less than 18. And when y is 9, 3 times 9 is 27, and that's greater than 18. Not so bad, huh? Let's move on. Oh, algebraic expressions can be compared by evaluating them for a given value of the variable. Okay, when b is 8, is 4b minus 6 greater than, less than, or equal to 26? All right, well, when be equals 8, let's see. Oh, is 4b minus 6 greater than or less than or equal to 26? So 4b minus 6, 4 times b, 4 times 8 is 32 minus 6. You get 26. Is it greater than, or less than, or equal to 26? It is equal to 26. So b is 8, 4b minus 6 does equal 26. Okay. Two expressions that have the same value are said to be equal when the two equal expressions are related by an equal sign, they form an equation. Okay, so the equal sign makes something an equation. Interesting. When c equals 15 is 3c divided by 5 greater than or less than or equal to c minus 8. So here's what you're doing. 3c divided by 5 or c minus 8. In each of those, you're going to plug in 15. So 3 times 15, 15 minus 8. 15 minus 8 is going to be a 7. 3 times 15 is 45. 45 divided by 5 is 9. 9 is greater than 7. When c is 15, this is greater than this. Ooh. I want you to pause me for 5 seconds and then fill this out. And when you unpause me, I'm going to start flying through it. Okay, pause me. Okay, so it asks us when d is 6, is 2d plus 10 greater than, less than, or equal to 4d? Well, when d equals 6, 2d plus 10 equals 2 times 6 plus 10, or 12 plus 10, or 22. And in this case, 4d is 4 times 6, or 24. So if 2d plus 10 is less than 4d when d equals 6. All right. If e equals 4, 4 minus 2 is going to be 2. 3 times 4 is 12. Divided by 6 is 2. It's going to be equal. If f equals 9, 8 times 9 is 72. Minus 4 is 68. And then 6 times 9 is 54. Plus 10 is 64. And that'll be greater. All right. Kind of just filling in numbers for letters right now. Oh, but here's where we're getting to the fun stuff. Some of you kind of hit the brick wall in this last week. And some of you might have done independent study. This is a skill that I probably picked up in late middle school, maybe 8th grade. But we're going to be talking about something called balancing equations. Or other times you'll see it written as something like solve for x, meaning what does x equal? So here's how this works. When you're dealing with an equation, I want you to think as if you are, I know this is a terrible drawing, but you're dealing with a set of scales, right? And you got a couple pan balance scales. I don't know what you've maybe done with those in science, but if you do something to one side of the equation, you have to do the same thing for the other. So look at this picture here. You have a balance with the letter A, and then 1, 2, 3, 4, 5 counters. And A plus the 5 counters, I lied, A plus the 4 counters is equal to the 5 counters right there. Okay? So there's 5 here, and that equals 4 of those plus 1 of these. Okay? Hopefully you're figuring out that this guy here is equal to one of those yellow counter pieces. Okay? So the way they're looking at this is they're looking at this as A plus 4 is equal to 5. Okay? If A plus 4 equals 5, what plus 4 equals 5? 1. Okay? That makes sense. That's kind of the simple version, right? So A equals 1. Now, here's the deal. If you put 2 more counters on each side, if you put 2 here, you put 2 here. So now you've got A plus 6 equals, let's see, a plus, so if you put 2 more on each side, instead of a plus 4 equals 5, you've got a plus 4 plus 2 equals 5 plus 2. So whatever you do to one side, you do to the other. So a plus 6 now still equals 7. 5 plus 2 is 7. A plus 4 plus 2 is 6. Okay? Now, what plus 6 equals, or what plus 6 equals 7? 1 plus 6 equals 7. So it is still true. Now, this seems really confusing and convoluted, right? All I want you to really be thinking about is the fact that when you are dealing with an equation, come on, give me the right color. Let's ignore all this other stuff. Ignore it, ignore it, ignore it. Ah. Okay, so when you're dealing with all that other junk, this 1 plus 6a equals 7a, just anything you do to this side, you must do to this side, and it'll stay in balance. Okay? So if you do the same thing, if you take away 2 from each side, if you do a plus 4 minus 2 and 5 minus 2, you're going to get a plus 2 equals 3, and your two sides are still going to be the same. You subtract a 2 from one side, you subtract 2 to the other, you keep it in balance. A still equals 1. You can also multiply or divide both sides by the same non-zero number. Okay? So, let's see. In this picture, we have 4a counters equaling 8. 4a equals 8. Okay? If I have 4a equals 8, I know that 4 times this is 8, or 4 times 2 equals 8. So a equals 2. This tells us that a equals 2. Man, I couldn't have picked a trickier lesson to be out for. If you double both sides, 4a times 2 becomes 8a, and 8 times 2 becomes 16. You've now got 8a equals 16, or 8 times 2 equals 16. A still equals 2. Over here you did times 2, over here you did times 2. Whatever you do to one side, you do to the other. Whatever you do to one side, you do to the other. Oh, it's going to be a long lesson. You can also divide each side. We originally had 4, we divided by 2, and now we've got 2a. And you have the 8, you divide it by 2, and you get 4. So 2a equals 4. A, 2 times what is 4? A still equals 2. Okay. Whew. We're getting to a point here, I promise you. Oh, so it says solve equations with variables on one side of the equal sign. So we're trying to figure out what that is right there. Okay. Curious to see what the book's going to tell you. Blah, blah, blah. Oh, they're just asking to guess here. Don't do that. Don't guess. Here, let me make it real clear. Don't guess. You got that? Don't guess on this. There's better ways to go about it. Again, we're trying to find in 5y minus 2 wait, what am I even doing here? It's my original number set. 5y minus 2 equals 13. Okay. Let's see how we're really going to do this. Boom. I disappeared on you too. Hopefully. Oh, wait. This might not work. Hang on. I better just come back. All right. Let's see. Okay. here's what you're going to do. 5y minus 2 equals 13. My whole purpose, my whole goal is to get this guy right here, get him all by himself. If I can get him by himself, then I can figure out what the y equals. Okay, so what can I do to get the y by himself? We'll see this minus 2 here. I want to get rid of any numbers that aren't remotely connected. So how do you get rid of a minus 2? You add 2. So you're going to go 5y minus 2 plus 2 equals 13 plus 2. Because remember, whatever I do here, I have to do here to keep it in balance. Okay, so now what that does, 5y minus 2 plus 2, I get a terrible color, but I also get 5y, and then 13 plus 2 is 15. Okay. The next thing I need to do is try and isolate this y. Well, I've got 5 times y. If I'm multiplying something by y, how do I get rid of that extra number? Well, 5y divided by 5, or if I have, what's that divided by 5? But remember, I have to do it both sides, so I do 15 divided by 5. And then 5y divided by 5 is y. 15 divided by 5 is 3. I learned that in 8th grade, I think. Sorry, you guys. But you can do this. I know you can. I know you can. And I think that's what they're going to show us on the next page. Added 2 to each side, then we divided by 5 on each side. You get y equals 3. Okay. Pause this one. Just try number 8, and then we'll come back to it. I'll come back. You pause me now. I'll come back in 5. All right, for what value of p will 6p plus 7 equals 37 be true? Well, 6p plus 7 equals 37. I want to get this p by itself, so the first thing I'm going to do is get rid of that plus 7. And how do I get rid of a plus 7? I subtract 7. So 6p plus 7 minus 7 is just 6p. 37 minus 7 is 30. Now I want to get rid of the 6. 6p, or 6 times p, divided by 6, and then I'm going to do 30 divided by 6, because I want to get rid of that. 6p divided by 6 is p. 30 divided by 6 is 5. So this is true when p equals 5. And yes, I want you to show me all steps. Show me this line, show me this line, show me this line, show me this line, show me this line. Maybe tomorrow I can show you a way to shorten it up, but I want you to show me all of those steps. Work with a neighbor. Do these next 2, and I'll show you how to do them on this page. I'm coming back in 5 seconds, so pause me now. Whoa. That's what I get for playing around. Look out. Yeah, that's all right. Let's hide me up here. All right. You're ready? 5r plus 5 equals 60. I want to isolate this r, so I'm going to get rid of that 5. 5r plus 5 minus 5 equals 60 minus 5. If you do it here, you got to do it over here. 5r plus 5 minus 5 is 5r. 60 minus 5 is 55. Then we're going to get rid of this 5 by doing 5r divided by 5. 55 divided by 5 is 11, and r equals 11. 5 times 11 is 55, plus 5 is 60. Okay, and let's do the next one. 3q minus 12 equals 15. Always going to get rid of that 12. 3q minus 12 plus 12 equals 15 plus 12. That cancels itself out. You get 3q equals 27. 3q divided by 3 equals 27 divided by 3. Q there, you get 9 there. That's it. Again, all 5 of those lines should be shown. Okay? Holy cow, this is a big lesson. Let's keep going. Okay. Now it wants us to solve equations with variables on both sides of the equal sign. That's not nice. It's the same idea, just with extra steps as I take a little sip of my tea. Man, I wish someone would have told me this lesson was this long. 20 out of... You gotta be kidding me, Holmes. All right, let's pause. There might be a pause break here. Hang on. Ooh, look at me. So after pausing and going to check the book on my other screen, my teacher instincts were true. And we're done with today's lesson. I don't have a separate exit slip drawn up for this lesson yet, so you don't need to do it today. I would say we're going to modify the assignment. We're going to do just page 205 in the workbook, and then I want you to practice the assigned IXL lessons. We'll come back in. We'll finish up this lesson tomorrow. So, yeah, this is a doozy. No wonder some of you guys hit the wall last week. So that's it for now. Just page 205, just IXL practice for chapter 5, lesson 4. No exit slip. I'm going to disable it right now, and then we'll come back and we'll finish this tomorrow. Do your IXL practice. Whatever you do here, you got to do here. That's it. As soon as I know what's going on with Charlie when he can go back to school, I'll let you guys know. This is a total bummer. I wish I was there. I wish my kid hadn't been exposed. I crossed my finger that he's healthy, but wish I was there with you guys too. So that's it. Every time I start getting my voice back, I start to lose it. So I'm going to cut it now. Talk to you guys tomorrow. Peace.